All right, this is chapter 4, lesson 9, qualitative graphs. Okay, so to analyze qualitative graphs, a little bit closer for you to see. To analyze qualitative graphs, the graph shown is a qualitative graph. Blank blank are graphs used to represent situations that may not have numerical values or graphs in which numerical values are not included. So in those two blanks, you're going to write qualitative graphs. Okay. So qualitative graphs. Okay, so here's an example of a qualitative graph, okay? So axes are labeled but do not include numerical values. You can see that I have no numbers here, right? You can see that the relationship between time and percent photos downloaded. So here's time. So over time, the percent photos go up. There's a little bit of lull, and then they go up again, and then there's a little bit of lull, and then they go up again, okay? So when I'm sketching qualitative graphs represent the essential elements of a situation in a graphical form. You can sketch qualitative graphs to represent many real-world functions that are described verbally. Okay. So basically this idea of sketching qualitative graphs. So I can describe a situation and you should be able to graph it. That's the whole idea behind them. All right. So situation number 1. The graph at the right displays the water level in a bathtub. Describe the change in the water level over time. Okay, so here's my graph, right? How am I going to describe this graph? So, at the very beginning, right, it increases. Then there is no change. There's a flat spot. And then it decreases. So it increases, stays the same, then decreases. So what do you think's happening if we're talking about bathtub and water? Okay, so if I'm increasing, that's probably me filling the bathtub. The water level's going up. Okay, so maybe, you know, you're running yourself a bubble bath. So you fill the water up. Okay, this is just hanging out in the bathtub. And then this is draining the bathtub. Okay, so you can see it when we describe it. At time 0, the water level in the bathtub is 0. The water level in the bathtub increases at a constant rate. Then the water is turned off and the water level does not change. Finally, the drain plug is pulled and the water level decreases at a constant rate until the water level is 0 again. Okay. So let's look at number 2. Number 2 says, a tennis ball is dropped onto the floor. On each successive bounce, it rebounds to a height less than its previous bounce height until it comes to rest on the floor. Sketch a qualitative graph to represent the situation. Okay, so the first thing I want to do, step 1, is draw the axes. Label the vertical axis distance from floor and label the horizontal axes time. Okay, so here I am. Distance from floor and time, because those are the two things that I'm measuring. Okay. Then I can sketch the shape of the graph. The distance, so I start up here, right, with my tennis ball. So here's my tennis ball. I drop my tennis ball, it goes down, and then it bounces. But it doesn't go back up to the full height, it's a little bit lower. It goes down, and then it bounces. Doesn't go back to the height, a little bit lower. Down and bounces. Down and bounces. Okay. It'll eventually get smaller and smaller until it's just on the floor, right? The ball falls to the floor, bounces, and rebounds to a height less than its drop height. This pattern is repeated several times until the ball comes to rest on the floor. Okay. So it can keep going. It could be less. There could be a little bit more, but it's still going to be about the same. Okay? Number 3, a child swings on a swing. Sketch a qualitative graph to represent the situation. Okay, so first I draw the axes, label the vertical axis distance from ground, and the horizontal axis time elapsed. Okay? Then I can sketch the shape of the graph. The distance from the swing to the ground starts at a low value. The child continues to swing and creates momentum each time the swing goes back until the child on the swing stops. Okay? So, I don't actually start on the ground, right? Because the swing's not on the ground. So I start right around maybe halfway. Swing forward, up, then we get really close to the ground, and then we go back up. We get close to the ground, we go back up. Close to the ground, we just stop. Okay? So it's like that pendulum that swings back and forth and back and forth, okay? So the swing goes back and forth. Okay. On the next page are the try-it problems. So go ahead, pause the video. There are 3 try-it problems. Try them out, and when you are done, we will go over the answers together. All right, so now that you've had a chance to try out the try-it problems, let's go over the answers together. Letter A says the graph at the right displays the temperature throughout the day. Describe the change in the temperature over time. Okay, so here's my graph. So if I'm looking at this, I'm describing it. I'm looking here. It starts pretty much at 0, 0. Okay, so this is probably, we'll say midnight, something like that. So eventually, over time, the temperature increases. It reaches a maximum temperature, and then it decreases back down. So the temperature increases slowly throughout the day. Reaches a peak and then decreases. Okay, that doesn't have to be your exact answer, but something along those lines. You're telling me that it is increasing and then it decreases. Okay. Letter B says the graph represents revenue from a local clothing store. Describe the sales over time. Okay, so here's my graph. Here's sales and time. And I can see that the graph is going to go, goes up a little bit down, and it goes up, but it keeps going up, right? So if I'm describing what I see, it says over time, the revenue, that's the money the store makes, the revenue increases. There are a few dips or places where it remains constant. Okay. Letter C says a car is traveling at a constant speed. The car slows down steadily to come to rest at a stoplight. Sketch a qualitative graph to represent the situation. All right, so step 1, I draw my axes, right? And I need to label my axes. So I'm going to label my axes with time, okay, because over time, that's what it's talking about. And I'm talking about cars slowing down, and it's constant speed and slowing down. So I'm going to talk about speed, okay? So speed and time. So cars traveling at a constant speed, Okay, so it's not changing, it's staying the same. Speed, 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 staying the same, staying the same, staying the same. Okay, notice I didn't start at 0, right? I didn't start at 0, 0, because they told me it was already traveling at a constant speed. It wasn't increasing to get there. It was already traveling at a constant speed. So here's my constant speed, and then it comes to rest slowly, so it decreases until it comes to a stop. Okay, so this constant speed decreases steadily until it comes to a stop. And that is the end of lesson 9.